You can learn a lot every day if you pay attention. Now, to understand the arrangement of electrons in an atom, you need to pay attention. Hello, this is Preeti Chhabra and welcome to Learning Never Stops. Today's video is about the electronic configuration. Now, what is electronic configuration? It is nothing but the distribution of electrons in an atom, the accommodation of electrons in an atom. Okay, what's an atom? Atom is the fundamental building block of matter, the smallest particle of any element. That is an atom. If you are watching this video, the video on electronic configuration, by this time you must have heard or must be knowing something about what is an atom, or you must have heard about protons, electrons, neutrons and all. Before coming to the topic, let's just quickly look at the atomic structure. Okay. Now, atom consists of subatomic particles. Now, there are more than 200 subatomic particles, but these three subatomic particles which are of much importance are electrons, protons and neutrons. Now, the electrons are negatively charged particles, subatomic particles. Okay. Protons, they are positively charged subatomic particles, and the neutrons, they don't have any charge, they are neutral. Fine. Now, every atom has a specific atomic number. For example, we can say that you all must be having a roll number in your class. Now, no two students can have the same roll number. Likewise, no two atoms, no two elements, no two atoms can have the same atomic number. The atom of every element has a specific atomic number. That atomic number is the number of protons that atom contains. Number of protons is always equal to the number of electrons, okay, which is equal to the atomic number. Now, basic structural part of an atom, if we look on, we find that structural part of an atom has two parts. One is the nucleus, the other is the orbits or the shells, which is also known as the extranuclear part. Nucleus is positively charged central part of the atom. Why positively charged? Because nucleus contains protons and neutrons, and together they are called nucleons. Protons and neutrons together, they are called nucleons. Now, since protons have positive charge and neutrons, they are neutral, they don't have any charge, so both protons and neutrons are placed inside the nucleus, giving nucleus a overall positive charge. Now, coming to the orbit part, the extranuclear part, orbits also known as the shells. What are these? These are the imaginary paths around the nucleus in which the electrons revolve. Now, this is the part that we have to study, the electronic configuration. So, moving ahead, these orbits or shells, how are they present inside an atom? This is the nucleus of an atom, which contains protons and neutrons, which is positively charged because of the presence of positive charge, protons. Now, see, this is the first orbit. The closest orbit to the nucleus is named the first orbit. The orbit which is closest to the nucleus is the first orbit. Okay. Then the second orbit, then the third one, then fourth, and like that it goes on. So, if we start naming them, the orbit closest to the nucleus is the first orbit. This is also called as the K shell. Okay. The next one is the second orbit, also known as the L shell. Okay. Then the third orbit, also known as the M shell, and likewise it goes on. Next is the fourth orbit, also known as the N shell, and like that it goes on. Fine. Now, how are these electrons accommodated? These orbits have some energy in them, and they have their particular energy level. Now these shells contain different electrons depending on the amount of energy associated with these orbits. Electrons revolve at a very high speed. They neither gain nor lose energy while revolving. They revolve in a particular orbit according to the energy level of that orbit, the energy associated with that orbit. Fine. Now these are distributed. The distribution of the electrons was suggested by Bohr and Buddy, and there were some set of rules. There are some set of rules which are followed for writing the electron number in different orbits. The first rule is that it always follows the formula 2n square, where what is n? N is the orbit number. Suppose I want to calculate how many number of electrons can the first shell accommodate. What is the capacity of the first shell to accommodate electrons? How will I find out? By using the formula 2n square. Now since this is the first orbit, so I'll put 1 in place of n. See, 2 into 1 square. This is 2 electrons. Fine. 2 electrons can be accommodated in the first orbit according to the rule. Coming to the second shell, again following the same formula, where n is now the second orbit. So it is 2 into 2 square, which is coming out to be 8 electrons. Likewise, we can calculate for the third shell, which is coming to be 18 electrons. Then the fourth shell, formula remains the same. This is 32 electrons, and so on we can calculate. This is the first rule. The second rule says shells are filled in stepwise manner. Stepwise manner means starting from the first shell. The first shell, which is closest to the nucleus, has the least amount of energy, so it can accommodate least number of electrons. We can see here it can accommodate only 2. Moving ahead, the second shell can accommodate more, that is 8 electrons. Then the third one, 18 electrons, even more in the fourth one, 32 electrons, and likewise it goes on. The last shell has the highest amount of energy and can accommodate highest number of electrons, like that it goes. So shells are filled in stepwise manner. The first shell, the electrons will be filled in the first shell first, or the first orbit, and then in the second orbit, then they'll move to the third orbit, like that. Okay. Then the third rule says that the outermost shell cannot accommodate more than 8 electrons. Now here I'll explain every rule with the help of examples so that the things become more clear. But while we are looking at the rules, just I'll tell you what does this mean. Outermost shell cannot accommodate more than 8 electrons. But here we see that the third orbit can accommodate 18 electrons. But here it says that outermost shell cannot accommodate more than 8 electrons. This rule is called the octet rule. Why? Because atoms, when they have 8 electrons in their outermost shell, they become stable. Now these electrons, why do they participate in chemical reactions? Because they always want to attain this state of stability, which they attain only when there are 8 electrons in their outermost shell. To attain stability, they come to a state whereby the outermost shell should have 8 electrons. For that, some electrons or some atoms give away electrons, some atoms take electrons. All these topics will be done in the upcoming videos. You don't need to mug up these rules, children. You don't need to simply learn these rules. You just need to, when I'll explain you with the help of examples, I'll tell you, you just need to practice electronic configuration based on these rules. And this is the most important point. This is the most important rule which you must understand. Okay, electrons. So how does the filling take place? How does the accommodation take place? We look into that with the help of some we'll be doing examples. It with examples. What you need to learn is these 20 atomic numbers. I mean the atoms with their atomic numbers. What rules we are discussing right now, these are for these 20 atomic numbers, because these are light elements. Okay, so these 20 elements follow these rules for the writing electronic configuration. Let's just randomly pick up any of the atoms. I'll start with helium. Why? Because this is the nucleus, protons and neutrons, positively charged. Now helium has atomic number 2. That means there are 2 protons and 2 neutrons. 2 neutrons have to be accommodated. I told you atomic number is equal to number of protons is equal to number of electrons. Now the atomic number of helium is 2. That means it has 2 electrons which need to be accommodated. How will we accommodate? See, this is the first orbit. Right from the first orbit we have to start, closest to the nucleus. First orbit, it can accommodate 2 electrons, and we have to accommodate 2 electrons. So this is the first electron, this is the second electron, done. But here it says that outermost shell cannot accommodate more than 8 electrons. That means it has to follow the octet rule to get stability. But here they do not have more than 8 electrons, or the electrons, the outermost shell cannot have 8 electrons because they do not have 8 electrons. Okay, this rule is called the Duplet Rule, and this is the rule only for helium, because helium is the atom which gains stability, or which is stable, which is an inert in nature, because it has 2 electrons, and the first orbit can only contain 2 electrons, and it has these 2 electrons following the Duplet Rule. Duplet Rule says that if the first shell has 2 electrons, and that is the outermost shell of the atom, in that case this atom has gained stability. Fine. Now pick up any other atom, say for example oxygen. Now oxygen is protons and neutrons. Oxygen atomic number is 8. That means it will have 8 number of protons and 8 number of electrons. 8 protons sit inside, 8 positive charges there. Neutrons, they are neutral. We will not talk about neutrons right now. We are only talking about protons and electrons. Now 8 protons sit inside the nucleus. Now there are 8 electrons to be accommodated, but the first shell can have only 2 electrons. Out of 8, 2 are here. How many are left? Out of 8, 2 electrons have been accommodated. 6 electrons are left to be accommodated. So coming up to the next shell, the capacity to hold electrons in the second shell is 8, but we have only 6. So 1, 2, 3, 4, 5, 6 electrons this atom will have. Okay. Now this oxygen will take part in chemical reactions to attain stability. That is a different topic, but electronic configuration of atom oxygen is 2, 6, since it has 2 electrons in the first orbit and 6 electrons in the second orbit. Okay. Now taking up for example say neon. Okay, neon has 10, so 2 in the first, and if it has 2 electrons in the first orbit, how many are left to be accommodated? 8. So suppose this is the neon atom, so it will have 8 electrons. Okay, now since it has 8 electrons, it has completed 8 electrons, and it has 8 electrons in its outermost shell without any chemical reaction. These type of atoms which have 8 electrons in their outermost shell, they are called the noble or inert gases. Okay, they never participate in any chemical reaction, because the very reason for the electrons or the atoms to participate in reactions is to gain stability. Since they are already stable, so they do not take part in any chemical reaction. Now coming up next, for example, say I take magnesium. Okay, it has 12. Its atomic number is 12. That means it has 12 electrons. So first nucleus with 12 protons, then the first shell, it will have 2 electrons. Still 10 are to be accommodated, but second can accommodate only 8. So it will have 1, 2, 3, 4, 5, 6, 7 and 8 in the second. 2 plus 8 make 10, but its atomic number is 12. That means it has 12 electrons. Two electrons are still there, which need to be filled. So we'll have the third orbit and 2 electrons will come here. So its atomic number would be 2 in the first, 8 in the second, and 2 together, total 12 electrons. Suppose chlorine 17. So it's simple, 2, 8, 10, 7 are left. So 2, 3, 4, 5, 6, and it will have 7 electrons in its outermost shell. If we talk about argon, then like neon, this will also have 8 electrons in the outermost shell. This is also a noble gas or an inert gas. Okay, it is also stable. This will also not participate in any chemical reaction. So done with argon. Now coming to potassium. Here you will get to understand this rule. How? This is the first orbit containing 2 electrons. This is the second one containing 8. Now this is the third one. It has 8 electrons, but it can accommodate 18 electrons. It has the capacity to accommodate 18 electrons. Potassium has atomic number 19. That means it has 19 electrons in it. Since this has the capacity to accommodate 18 electrons, I can write the 9th one here. But no, this cannot happen. Why it cannot happen? Because this rule says that outermost shell cannot accommodate more than 8 electrons. This has gained stability. Where will this extra 1 electron go? It will go first shell with 2 electrons, second shell 8, 2, 3, 4, 5, 6, 7, 8. Third one will also have 8. 1, 2, 3, 4, 5, 6, 7, 8. This extra 1 electron will go to the fourth shell. Okay. You don't have to learn these rules. I'm again telling you. You just need to learn these 20 atomic numbers, 20 atoms with their atomic numbers, and you just, what you need to do is practice any 3 to 4, 2 to 3 configurations daily. Okay, so talking about calcium, this would be 2, 8, 8. Okay, making it 18. Then 2 electrons would be left. So one is this and the other one would be this. So calcium electronic configuration would be 2, 8, 8 and 2 and not 10, because this rule says outermost should not have more than 8. Fine. So I hope I am clear. So I end up my video here. Thank you for watching this video, and hope to see you in my next video, where I'll be teaching you the valence electrons, valence shell, valency and some related topics. But for that you need to subscribe to this channel, and till then, stay home, stay safe. Bye bye. Thank you.